Hello and welcome to my talk Beyond Relational with Entity Framework. In this talk, I will talk about some interesting features of Entity Framework and SQL Server databases. I will talk about how to keep non-relational data in your relational database with JSON data. I will talk how you can keep the history of your tables with temporal tables and how to work with hierarchical data with Entity Framework Core. So a little bit about me. I have 15 years experience working with C# and .NET. Currently, I'm a tech lead at Space International, and I work mainly with backend platforms. So I use Entity Framework and SQL Server in my day job. You can find some of my open source projects on my GitHub, and you can also check my websites for my occasional blog posts. So today, let's start with JSON data. So JSON, as you probably know, is an open standard for exchanging data between various systems, various platforms, or between APIs. It's human readable and lightweight and easy to parse and generate. So it has become quite popular and common nowadays. The most frequent use cases are to exchange data between different services, between different platforms and services, to transmit the data, to return the data from the service as a JSON, and to also store the unstructured data. And here is what a JSON looks like. So why store data in JSON in a relational database? Well, one, it has several benefits. If you have a relational database and most of your data is relational and you don't need a dedicated document database, you could just store data as in a non-relational way. It will allow you to denormalize your data. You can store nested structures in a single item and avoid complicated joins between tables. And you will be able to fetch all the data in a single query. And also, in some of the situations where schema flexibility is needed, for example, if you are an e-commerce shop and you have different types of products that you are selling, for example, TVs, mobile phones, and so on. All these products have different attributes from each other. Some of the attributes are applicable only to phones, some of them only to TVs, and so on. So if you need to design a database schema for these products, you would either need to create different tables for different types of products or have one big table with many columns. But the best approach would be to just store the attributes as a JSON in the database. So you avoid all the disadvantages of the previous approaches. Another common use case is to store the real-time analytics, for example, or data from IoT sensors or some other real-time data. And finally, you can also, if you need, for example, for auditing purposes, you can store API call, request and response, or just store the JSON data that was passed to your service from another service as a part of the webhook. So if your data is mostly structured, but you have some small amount of non-relational data, you can just store it in your relational database as well. So let's see in SQL Server how it works. In SQL Server, there is no dedicated JSON type. You store it in ordinary varchar or nvarchar columns like any other text. But SQL Server gives you some JSON functions that we can use to query and modify the JSON data or extract the individual attributes from the JSON columns. And also SQL Server allows us to create JSON indexes so that our queries on JSON columns are fast and we get improved performance. So here is what a JSON query looks like in SQL Server. If we have the employees table with a billing address column that contains JSON data, we can use the JSON value function to extract the city from the billing address column, and we can also use the JSON value in the where clause to filter the rows. So with this where statement, SQL Server will only return those rows that have states equal to New York. So there is no additional. So all the filtering is done by the entity framework by the SQL Server in the database. So starting from Entity Framework Core 7, Entity Framework supports working with JSON columns. We can filter by the properties of the JSON objects that we have. We can also make updates, like you update any other data with Entity Framework and expect the change tracker to save the changes. It works the same way for the JSON columns. If you modify a property of the JSON column, the modified property is sent to the database. In version 7, Entity Framework supports only SQL Server, and there is a separate implementation for Postgres. But starting from Entity Framework Core version 8, which will be released in November, there is also support for JSON in SQLite. And there are also some improvements for mapping the JSON. One of the improvements is that if you have a collection of primitive types, like for example, you have a list of strings or list of ints or list of datetimes and so on, Entity Framework will automatically store this column as a JSON in the database. And if you have a JSON property in your entity model, which is a collection, you can now drill into this collection and filter based on some condition for specific item. So let's see live demos now for JSON. I have prepared some data. So here we have the employees table, and as you can see, the contacts column is a JSON array. It can contain one or more contacts. We also have a billing address column, which is a JSON object, as well as primary contact. It is also a JSON object. And finally, we have the links column, which is a JSON array of strings. So no nested object here, just an array of strings. So in the code, I also have the same entity for this table. I have the employee class, which has a list of contacts and the billing address, the primary contact, and a list of strings, which corresponds to the columns that I have in the database. So the contact, you can see it has a nested navigation property, which has some other properties on its own. So first, let's see how the entity is configured in the data context as a to store these properties as JSON. So we can see here that the billing address and the primary contact and the contacts properties, these properties are configured as JSON with this toJSON method call. This tells entity framework to that these properties should be stored as JSON. And so if you are starting from the classes and generating your database from your classes, and the migration will take it into consideration and not generate a separate table for these columns as well. You will also notice that there is no configuration for the links property that I have here. This is because entity framework is smart enough to figure out that this collection should be stored as JSON, so there is no extra configuration needed for this property. So now let's see how we can work with this data from entity framework. I have the context created here for and here is a query which is pulling all the employees that have the billing address states equal to Georgia. So as the state is inside the inside this address details class, let's see what happens when we run this query. So here is the generated query printed on the console window, and you can see that the generated query is doing filtering based on the billing address column, and it's extracting the state from the billing address, and it's doing the filtering so that the state is equal to the value that we passed. So even though there is no explicit state column in our model, and we are filtering on the nested property of this JSON object, entity framework is able to generate the corresponding SQL query. So the filtering happens on the database, and we won't be pulling any records from the database that don't match our condition. So now let's just pull one record from the database and modify the state state of the records and see what state changes is doing. So because so the state was already equal to this value, so it's did not send anything to the database. But if we set we do it again and set the state to a new value and say the changes to the database. Here is the generated update statement, and we can see that entity framework is using the JSON modify call, the JSON modify function call, and it will set the billing address to the current billing address, but it will modify the state property of billing address to the value of the parameter that is passed to this statement. So because we are modifying only the state property and nothing else in the billing address, and the update statement that is generated by entity framework will only send the value of the state that we wanted to set, and will modify only the state portion of the existing JSON in this column for this record. So let's see now what happens if we try to update two columns in the JSON, two values inside the JSON. So I will set the states and postal codes to some new values and call save changes again. And this time, if we check the generated update statement, we can see that instead of modifying the individual attributes of the JSON, it's sending the whole billing address as a JSON. You can see it here in the parameters. So this is the whole billing address sent as a JSON to the database for the update statement. So this is the way entity framework works with JSON. If you modify only one property, it will send to the database only the individual attributes that you are modifying in the database. But if you are modifying several properties, it will update the whole JSON object. So let's see some more examples. This is new in Entity Framework core. So remember, contacts is a collection, and it's stored as JSON. So here we are filtering based on the contacts. We are getting employees who have contacts whose name starts with John. So before Entity Framework version 8, this query would not work, and you had to write it manually with SQL yourself. So if we run this query and inspect the generated statement, we can see here it generated the filter condition for our query. So it's using the OpenJSON function from the SQL Server database to get the JSON inside the context and do the filtering for the contacts and return only the corresponding rows. So I'm using the preview version of Entity Framework core, so that's why it works in this demo. So if you try it with Entity Framework 7, it will fail. So don't forget to update to Entity Framework version 8 if you want to try this before the official release. So this new features which allows us to filter by the contacts by the collection. It also works for projections. So if we find employees who have at least one contact, we can now also use this new functionality in the projection. So we can select the name and the phone of the first contact, and also get the total count of the contacts. So if we run this query, we will see that Entity Framework will include it in the select clause as well as the where clause. Entity Framework can also filter on the nested properties. So here we have primary contact rules dot maximum messages per day, and the generated SQL contains, as you can see, again JSON value, but now here we get the whole path for the nested objects. And we can also modify the network properties, which will get saved to the database. Again, the whole JSON is sent to the database. And also regarding the primitive collections, which is the new feature in Entity Framework 8, we can find we get the employees who have links and inquiries.com, and we can modify the collection as well, remove the item, add a new item, and Entity Framework core will generate the corresponding where clause for us and generate the update so that the primitive collection is updated in the database. So this is for the demos. One more thing is for performance. Every time extracting the individual values from JSON can slow down the engine of the database. So for this, we can create indexes to speed up the performance. And to index the JSON columns, we need to create a computed column on the table. This is the example of creating a computed column which extracts the state from the billing address column, and then we use this computed column to create the index. And we can also do the same in Entity Framework core. We can see here in the configurations that we have a state property, which is defined with has computed column SQLs. This means that this state property will be generated in the database as a computed column. It will not take any additional space, but it will contain the state from the billing address column, and then we can use the asIndex method that we use in Entity Framework for any kind of indexes, and we can create an index on the state column. So this is how JSON works with Entity Framework core. Next, we move to the temporal tables. So with temporal tables, as I said, we can keep track of all the history of the table. And for this, so temporal tables is a feature of SQL Server. With temporal tables, every table, the table gets two new columns, daytime two columns that are used by the system to record the validity start date and end date of every row. And we also get a new history table, which is used to keep the history of our data. So the main table will store the current values, and the history table will store the history of our data. And this is the example of how to create the table manually. But we will see in our demo that we can also create temporal tables with Entity Framework. It's just for example how we can specify the period start and to see that we have the period start and period end columns. So when working with temporal tables, you cannot insert or update the period columns. So the period and the period start table, period start columns cannot be, the values cannot be specified manually. You can't also make any changes to the history table. You can't delete or update rows from the history table, but you use the main table the same way you use any other table. You can query, insert, or update the table that you do with non-temporal table. The period columns are hidden from the user. So if you don't explicitly include it in your select query, you won't get the values for the period columns. So why use the temporal tables? It's frequent to need data auditing for your tables. So if you want to keep the history and know what changes were made and when the changes were made, or if you want to do trend analysis, for example, to make some to get some insight from your data, like how the value was changing over the time, or if you want to implement comparison of versions between different times and allows the users to undo the changes, you can use the temporal tables. It also has some disadvantages, like there is no built-in way to restore data, so you will have to implement that manually. So with temporal tables, let's see how the temporal tables look in the database. I have a database with temporal tables. So we have the persons table. You can see it says system version because it's temporal, and there is the second person's history table, and this is the table which you store history for the person's table. So if we select the rows from the current table, it has some rows. You can also see period start and period end columns, which indicate when this record became active. And if we take this ID here, and if we query the history table, we will see all the changes that are made to this record. So let's run this statement. So you can see this is the earliest record. This was created on 24th and was active until 25th. And the values of the first name and last name were this. Later, I changed the values to my name from on the 25th at this time. And this was active until today morning. And the current value, which became active after this time, is in the current table. So you can see that this period start is the same as the period end here. And the current value is again my name, but in Georgian, and this is the current valid record. So how do you query the temporal table? For current data, you just query the current data the same way that you query any other table in SQL Server. And for historical data, you query it with the additional for system time clause, and SQL Server gives us the option to query the historical data for different in different ways. We can use as of clause to get the data that was current at the specified time. We can get all the records that were current from one date until another date with the from, to, or between and end clauses. We can also use the all clause to get all the data, including current as well as historical data. And we can also use the contained in to get all the rows that became active and inactive in the given period. So to use temporal tables with Entity Framework Core, no additional NuGet packages is required. It's all supported from EF Core version 6. The only thing is that when configuring the table, you just need to specify the table as temporal with the isTemporal method call. You perform the CRUD operations on this entity on just like the way you do it on any other table. And you can also query the historical table using the new query operators, which corresponds to the clauses that I showed here on this slide. So we have the methods temporal as of, temporal between, and so on, which we will see in a moment. Just keep in mind that when you query the historical data, because there is no way to update the historical data, there is also no change tracking for the historical data, because it does not make sense to track the changes made to the historical entities, because there is no way to save those changes to the database. So let's see the demos. So as I said, the only configuration needed is we specify that these tables we want it to be temporal. Is the isTemporal method call, and that's all. No other changes when configuring our model. And let's see how we can query the data. So here I have this query that is getting the persons with the data that was active 10 hours ago. So let's run this. So here we can see that this first record, this has my name in Latin alphabet, because 10 hours ago I have not made the change yet, which changed my name in Georgian alphabet. So that's why we see this values in. So these values are coming from the history table, and if we look at the generated query, we can see that it's generated the for system time as of and the dates time 10 hours ago that I passed. We can also when selecting the data from history table, we can also use shadow properties to get the values of the period columns, because the period columns are not part of our entity model. So we use this ef.property syntax to get the period start and period end calls. So I'm here selecting all the records that were active from starting from 3 days in the past until current time. Because of this contains 51 records, but so the one record is coming from the history table and 50 records are coming from the current table. And again, if we look at the generated query, here we see now it uses the for system time between and passes the 2 dates that I passed in the query. So one more interesting feature of temporal tables is that if you have two temporal tables, and if you are joining between them, which I'm now doing in this next statement, I'm including the address navigation property. I'm getting the record that's corresponding to me that was modified, and so this will fetch the current. So this will fetch the current information. So it will show my current name and some current address. But if I do as of in the past, it will now get so my first name and last name now are coming from the history table, but the address is still coming from the current table. But if I now go in the past a little bit more with minus 20 hours. We can see now that my name is still same. That was 10 hours ago. But I think I need to change the time a little bit more. Yeah, so if we do this, if we try this 30 hours ago, we can see that the name as well as the address is now coming from the history table. So when you are using include, both tables, persons as well as the address table, both of them are queried for this time, and we can see it in the generated query as well. Here, for system time as well is specified for the persons table as well as for the addresses table. And it's using the same values for both of them. And now let's try deleting this record. If we delete the record with ID that we just saw, we can now see in the table that this record has disappeared from the current table. But if we select the data from the history table, we can see that the record that was current before we started the demo is now in the history table as well. Now, just keep in mind that if you want to recover data from the history table, there is now no such functionality built into the either SQL Server or Entity Framework. So you will have to implement it manually. And one thing to keep in mind is that if the ID is auto-generated, if you select the data from the history table like I did now, so this deleted variable points now to the record that was deleted. It's just temporal and sorted it in descending order and getting the first one. So it will get the value that was deleted. If you insert it in the persons table again, because the ID column is identity and automatically generated by the database, it will now get a new value. So if we query this table again, we can see that this record now has an ID of 52. So even though we inserted it again, there is no way to get the old ID back. So it might become tricky for you to delete and recover to track which record was which one. That was the demo of temporal tables. A few words about the limitations of temporal tables. If you are storing large amounts of data in your table, like globes or annual charts or so on, then the size of the history table will also become huge. Truncate operations on the tables are not supported by the temporal tables. Also, you don't get any primary or foreign keys for the history table. This is because for one record, you can get many records in the history table. So obviously, there is no way for the primary key to work. And there is no built-in way to undo changes. So you will have to implement it yourself if you want to undo some changes based on the historical data. Now let's move to hierarchical data. So first of all, what is hierarchical data? Anytime you work on a human resources application, for example, where you have the organizational structure with people reporting to another people in the organization, or you want to represent file system data in the database for some reason, or you have tasks in the project and you have some tasks that are children of another tasks, and so on and so on. Or you have pages on a website. All of these are examples of hierarchical data. And if you have worked with it, you probably know that it can become tricky to query the ancestors and descendants of the data. So that's for this reason, there is a built-in hierarchy ID type in SQL Server, which has some useful functions for querying the hierarchical data. So here is an example how you can how they how you use the hierarchy ID. You use it the same way, just like any other database type. Here we can see that we have the positions table, which has path column, which has the type hierarchy ID. So the hierarchy ID is stored in the database as binary, and it has this interesting feature that if you have two nodes which are hierarchy ID values, you can always generate a new node that is in between these two nodes. But hierarchy ID also has some disadvantages. Well, not disadvantages, but some shortcomings that you should keep in mind. For example, if it does not enforce any uniqueness, and or it does not make checks for cycles, and you can have one record which is pointing to another record in the same table, and have that same table and have that same item reporting directly to the same item, so you can get cycles in the database, in the data. Or if you have record A which has child record B, if you delete if you delete the parent, the A item, you get B with no parent, so there is no built-in way in hierarchy ID that checks for validity of your data. So the hierarchical relationships are not enforced on the database itself. You need to make sure in your code that you don't insert any invalid relationships between the hierarchies, or you don't delete any records so that you leave children without parents. Hierarchy ID type comes with some helpful methods, as I said, to get either ancestors, or get the level of the current item, or get the descendant. So this will help to simplify querying the hierarchical data in your database. Entity Framework supports hierarchical ID starting from version 8. Again, this is a new feature, so you will have to use the preview versions if you want to try this out. You need to install the package from NuGet, which includes the hierarchy ID type, and once after that, you simply configure the in your data context to enable hierarchy ID with this method call. So let's see some demos for hierarchy ID. So I have first look how the hierarchy ID looks in the database itself. So you can see that this is the path it looks, this is the binary representation. But in your code, in our code, the same data looks like this. So this is the root node, this is the first child, this is the child of the first child, and so on. This is second child, these are children of this node, and so on. So you can use this human readable text to parse the human readable text into the internal binary representation. And as I said, you just need to use the use hierarchy ID to enable the hierarchy ID in your project. So let's see how we can work with the hierarchical ID from entity framework core. Let's first, I have the query which gets all of the data and renders it as a tree so that we can see what data we have. So here we have the CEO and we have different deputies and so on. So this is the representation of the positions tables that we just saw. So this table, when you convert it to hierarchies, this is how it looks like. So what can we do with hierarchical queries? For example, we can get all the positions on the specified level. For example, get all positions on level 2. We just do the query like this for every position. If the pass level is equal to desired level, it gets returned to us. And the query is, and the generated query includes the call to the get level method. So all the filtering happens on the database side again. So this will return all only those positions that have level 2, and we just print it to the console. We can also find the descendants if we are interested. For example, to do that, we use the is descendant of. So we get one of the positions from the database. Then we find all the records that are descendants of this path. The only thing is that SQL Server considers the item to be descendant of itself, so we need to include this inequality here to exclude this item itself from the result set, and then we just order it by level in the ascending order. And again, if we look at the generated query, we can see that Entity Framework converted our query to the is descendant of method call here. And order by calls also includes the get level and pass. So this is how we find descendants of some specified item. We can also use it to find ancestors. We just switch the positions here in the where condition. So we get the position, some single position from the database, and then we find all the ancestors of this position in the organizational structure that we have. And again, the generated query contains the call to is descendant of. The hierarchy ID also comes with the get ancestor method, so we can use it to find the direct ancestor of some record. So if we have this title, we can find the position that is the direct ancestor for this item. And again, entity framework just translates it to the get ancestor call on the SQL server side. Also, a common task in when working with hierarchical data is to find common ancestor of two different items in the data. For example, here we get this two positions from our table, and we use this query, so we find all the descendants, so all the positions that this position is descendant of, and all the items that this second position is descendant of. And when we order them in a descending order, we will find the common ancestors for these two positions. Finally, we can see how we can add a new item to our tree. For example, if we want to add someone to be a descendant of this item, first we need to find all existing descendants so that we know where, so that the new item is the next item for this descendants. So if we find existing descendants, then we find the maximum pass. So the maximum pass in our case is 1/2. So the next descendant of this item will be to get the position for the new item. We call the get descendant method. We pass the existing maximum pass of the descendants. So the new item will be descendant of this item. So it becomes 1/3. So it will be in the tree, it will be next to the on the same level as descendants, but next to the rightmost descendant. So if we create this new position here and call their changes, we can see that entity framework is sending the human readable value for the class, which will get inserted in the database, and we will get a new item in the tree below this record. So that's all from my presentation. I hope you enjoyed it, and if you have any questions, I will be happy to answer them, or reach out to me on Twitter or on GitHub.
Yeah, I added myself back already. Rachel will also come.
Here we go. Yep.
Thanks, Giorgi, for this session. It was nice. We actually have a lot of questions, so let's dive right into. Yeah. So my first question was, what brought you to the idea of going kind of beyond relational?
Well, for JSON, I had to use it in one of the projects, so I actually had to use it in one of the projects, so that's how I got into it. The other ones, the temporal tables, I found it on the blog of the entity framework core team itself. So it solves many problems that I have solved in the past with some tricky code and some clever code, and there is so many hassles. So it's like, why did not I have it in the past when I needed it? So I think it's a useful feature, and same applies to hierarchical data. If you have used it, you know that you have to use common table expressions for recursive queries, which can be a pain to write and to read later. So these features provide many helpful features that I wish were available when I was working with them, when I needed it.
Gotcha.
Yeah.
Rachel, you have the next question.
Yeah. So, Lucky Uranium was asking, what are the minimum versions of SQL Server or Azure SQL that support these features? And a sub question of that is, are temporal tables and EF still only supported with Microsoft SQL?
Yes, so temporal tables are only supported with SQL Server only because it's only supported by SQL Server database itself. So other databases don't support this feature. So obviously, Entity Framework can't support the temporal feature if the database engine itself does not support it. But I don't remember the exact versions of the database of the SQL servers that supports this feature, but I think any modern SQL server will probably support it.
Okay, so second question from me, and actually also from chat. Is there a way to prevent Entity Framework from updating the entire JSON when updating 2 or more fields? For instance, if you modify only 2 fields in a big JSON structure, or does that perform worse? Let me add also a second question about performance. Which one performs better, manipulating data inside JSON column or dedicated table column?
Yeah, so for the first question, I think I'm not sure, but I think it was implemented like that it's sending the whole JSON because the Entity Framework in itself found that doing 2 round trips to the database was actually slower than just sending the whole object in one network call to the database. So that's why they implemented it this way. They are just doing only one network round trip to avoid extra network call. But if you have a huge JSON and want to only update 2 properties and not send the whole JSON again, the simplest thing probably would be to call 2 save changes between these between saving these 2 properties. Now it may not be desirable, or it may not be possible because the code also will get messy, but I don't know of any other way to update. Or maybe you just update it with raw SQL and don't use Entity Framework in such case.
Okay, I'm not too sure. We might not have too much time to ask more questions. What I would like to ask.
A quick, easy one though.
Okay.
Yes, no, which is, can you add constraints to the JSON properties?
Strings?
Constraints.
Constraints? In SQL Server, no. I think the only constraints that you can add is to ensure that the column is actually in valid JSON, and that's all. No, but no, you can't add any constraints, I think, in no database at all. So if you want to enforce relations, then don't use JSON and use ordinary columns.